The law of conservation of energy states that energy can be neither created nor destroyed. We see this in our everyday lives, such as when I throw out this ball. To demonstrate the conservation of energy, I built this elastic launch glider, which will show the transfer of energy between 4 different types of energies. But before we continue, we need to know these 4 types of energies. Pause the video here if you need to review these formulas, but if not, let's continue. Now it's time to fly. Here I am, using a rubber band to launch my glider.
I believe I can fly. I believe I can touch the sky. I think about it every night and day.
Pretty cool, right? Now let's look at the energy transfers throughout the flight. At first, there's only elastic energy and gravitational energy. The glider starts off at a height of 1.49 meters. The mass of the glider is 0.00561 kilograms. The elastic energy equation 1/2 kx squared only works when the k is constant, and that's very rare in real life. So to find the energy of the rubber band, which is the same thing as the work done by the rubber band, we need to find the integral of the function of the rubber band's force from 0 to the maximum stretch of the rubber band during the launch. To find the function of the rubber band's force, different masses were hung on the rubber band launcher, and the stretch of the rubber band was recorded each time. The force of the rubber band is equal to the force of the gravity, and therefore just the mass times gravity. I got 4 data points, and then I found a function that fits the data nicely. Now we can integrate this function from 0 to the rubber band's maximum stretch during the launch, which was 0.2987 meters. This gives us 0.422 joules for the elastic energy. The gravitational energy was found using the previously stated mass and height. The sum of these two energies gives us the initial energy of the glider, 0.504 joules. At any point in time, the total energy will always be 0.504 joules because energy is conserved. Now let's analyze the peak of the flight. The glider has no velocity and it only has gravitational energy. It has lost some energy to thermal energy. The glider has a height of 7.671 meters at this point. This height can be plugged in to find the gravitational energy at this point. The thermal energy at this point is the initial energy minus this gravitational energy. We can see that air resistance has had a small effect on the glider because the thermal energy is very small. And of course, the total energy is still 0.504 joules. Near the bottom of the flight, there's a tiny gravitational energy and some kinetic energy, but most of the glider's energy has become thermal energy. Here are the calculations for the 3 present energies, and once again, they add up to 0.504 joules. Now it is clear that air resistance has had a large effect on the glider's flight. At the end of its flight, all the glider's energy has transferred to thermal energy.